Welcome back. In this video, we're going to look at how to identify limiting and excess reagents and also how to use those things to calculate the theoretical yield. The first question we should ask ourselves is, do we understand what limiting and excess reagents are? In a reaction, a limiting agent is going to be the thing you run out of first. Often when we're doing experiments and combining different chemicals, we don't have exactly the correct ratio. And so in that case, one of them gets used up before the other one does. That thing that gets used up first is the limiting reagent. You can also call it a limiting reactant. Both are correct. The excess reagent then are the things that there's too much of, that there's leftovers after you've used up one of the other ones. In the next video, we're going to actually look at how to calculate how much excess we have. But for today, we'll just focus on the limiting reagent. To understand better what we're talking about here with limiting reagents, we're going to use an analogy. If we went to the grocery store to go shop to make some hot dogs, and we buy a package of hot dog buns, generally those buns are sold in packages of 8, whereas the weenies are sold in packages of 10. So if we're making hot dogs, the greatest number of hot dogs we can make would be 8, because at 8 we run out of buns. That means that the buns would be our limiting reagent, and the weenies would be our excess reagent, because we would actually have 2 leftover weenies after we had made all the hot dogs we could. In the same way, we also do this with chemicals and chemical equations. We're going to look at an example problem after we go over the steps we're going to follow. I'm going to leave a copy of these rules on the left-hand side of the page so that we can be sure we're checking them off as we go. But we'll overview them right now. First step, just like always, we make sure that our equation is balanced. Then we'll convert anything that's given in the equation into moles. Then we're going to find what's called a required ratio and an actual ratio. Fourth thing is we'll compare our ratios and then use whatever substance was limiting to calculate our theoretical yield. Our example is this one. 3.23 grams of ammonia are allowed to react with 3.5 grams of oxygen. How much water is formed? Our first step is to make sure that the equation is balanced. In this case it is. So we are able to check off step 1 and move on to step 2. In step 2, it tells us to convert our givens into moles. Reading from the problem, our two givens are 3.23 grams of ammonia and 3.5 grams of oxygen. We're going to use the molar ratios to change from grams into moles. So 1 mole of ammonia is equal to 17.04 grams of ammonia. We use that to cancel out our grams and leave us with 0.19 moles of ammonia. We'll do the same with oxygen, using oxygen's molar mass, and that will allow us to know that we have 0.11 moles of oxygen. At this point, we've now done step 2. We'll move to step 3, where we look at ratios. One of the ratios is going to be what we've just found here in the problem. The two numbers that we have found, 0.19 and 0.11, will be made into a ratio. This ratio is called the actual ratio because it is the things that we actually used in our experiment, in our chemical equation. So in this case, we have 0.19 moles of ammonia to every 0.11 moles of O2. When we divide those numbers out, we get a number equal to 1.73. Now that we've found our actual ratio, we'll also find our required ratio. A required ratio is the numbers that we find from the chemical equation. What are we required to have as a ratio of ammonia to oxygen in order to make this equation proceed? So we get those from the coefficients that are listed next to our substances in the equation. We bring those down, we have a 4:5 ratio of ammonia to oxygen. That is the ratio that is required for this reaction. And then we do 4 divided by 5 is 0.8. At this point, we have found both the actual and the required ratio, and we'll be able to go ahead and compare them. When we compare 0.8 to 1.73, they're obviously not equal. In this case, the 1.73, the actual ratio, is greater than the required ratio of 0.8. What this tells us is that we had more ammonia than we needed to react with the amount of oxygen that could react. In that case, that means that our NH3, our ammonia, is the excess reagent, and the oxygen is the limiting reagent. If there had been exactly the right number of ammonia to oxygen, we would have had an actual ratio that also was 0.8. In this case, we didn't. Since the number on top was greater and our number on top was ammonia, that meant that the ammonia was the excess reagent. If our value had been less than 0.8, then that would have flipped it. And so that would mean that we didn't have enough ammonia to react with how much oxygen there was. And so we would flip them, and the limiting agent would have then been ammonia and the excess one oxygen. So now that we know which of the reagents is limiting, we're going to use that one to be able to find the theoretical yield. Theoretical yield, we should also define to be sure we know what we're looking for. So it says the maximum amount of product that can be made with a given quantity of reactants. In this case, we know how much oxygen we had. We know that the oxygen is going to be completely used up. And so we're going to use the information given to us from oxygen. We'll use that amount to then figure out how much water is formed, since water is one of the products. We'll find out the theoretical yield of the water. Because earlier we already converted the 3.5 grams of oxygen to moles, I'm going to go ahead and start from that step, since we already know how many moles of oxygen there are. Then I'm going to use the ratios of water to oxygen to convert into the unit we're looking for. In this case, we have a 6:5 ratio. We'll then multiply by the molar mass to convert from moles of water into grams of water, which gives us an answer of 2.38 grams of water will be formed when we use 3.5 grams of oxygen. At this point, we've now found our theoretical yield, and we have finished the problem. If this method makes sense to you, and it's something you feel confident with, then I want you to stop watching the video at this point. If this is a way that you find frustrating, I'm going to show you an alternative method that some people find better to use. It makes it clearer in their head. So if the one I've showed you already makes sense, you don't need to watch the rest. If this one is confusing to you, let's look at the alternative one and find out if that one is easier for you to use. Here's our steps here. Again, always make sure the equation is balanced. Then we're going to convert both reactants into grams of the product, and then we'll find out which one produced the least, and that one would be the one that had limited our equation. We'll use the same example to do our second method here. Again, these were our steps. Our first step was to be sure the equation is balanced, which we've already done. Now we're going to convert both reagents that we have given in the problem into the product of water which is the one we're looking for. We'll go ahead and do ammonia first. We'll convert grams into moles, and then we'll use the molar ratio to convert between moles of ammonia to moles of water. And then we'll convert from moles of water into grams of water, which gives us a value of 5.14 grams of water. So we'll keep this value saved for a moment so that later we can compare after we've converted the oxygen. Here we go with converting the oxygen now. We start with 3.5 grams. Using the molar mass ratio, we'll convert into moles of oxygen. Then we'll convert between moles of oxygen to moles of water. And finally, we'll convert the moles of water into grams of water, giving us a value of 2.37 grams of water. At this point, we now have converted both of our reactants into the product of water, and we're going to compare them now. When we look at those two, we look at which one produces the least. So in this case, the 3.5 grams of oxygen producing 2.37 grams of water is the most that amount of oxygen can produce, and so it is our limiting reagent, because the ammonia would have been able to make more, and we can't get more than the oxygen is capable of doing. So our oxygen is our limiting reagent, ammonia is the excess reagent, and a total of 2.37 grams of water are produced, which is the theoretical yield. I hope that one of those two methods has made sense to you and is easy for you to do. In our next video, we will calculate how much excess there is when doing a chemical reaction. Hope to see you next time. Have a great day.